Hey everyone, welcome back to the channel. Today we're going to look at how we do conduit fill calculations, looking at the Canadian Electrical Code Rule 12.9.10, sub-rules 4 and 5. So I'll just kind of slide that over now, and we'll just kind of go through it before we do our calculations. There'll be a bit of bouncing around here. There's a lot of tables involved, but the process in itself is pretty straightforward. All right. So obviously we can only put so many conductors into a conduit. If we overfill that conduit, we're going to start damaging the insulation, the conductor itself. It becomes too full, right? So we're limited to how many conductors we can put into a raceway. And whether that's PVC, EMT, DB2 ducting, right? Some kind of raceway, which is designed to contain conductors, right? We're limited to how many we can put into that raceway. All right, so looking at sub-rule 4 of Rule 12.9.10, the maximum number of insulated conductors or multi-conductor cables in one conduit or tubing shall be such that the insulated conductor or cables and their coverings will not result in a greater fill than that specified in Table 8. Well, what is Table 8? Let's go have a look at this one. All right, so it's a very simple table, very small. On the left you have insulated conductors or multi-conductor cables without a lead sheath, and the only other option is lead sheath single conductor cables or multi-conductor cables. So you got two options here, right? And when you go along that row, in each column over here, we have maximum conduit and tubing fill in percent, so a percentage of maximum that we can fill that conduit. And it's based on the number of insulated conductors or multi-conductor cables. So if you only have one, then you're allowed to fill that conduit 53%. And if you have two, then 31%. And then basically three or more, you can only have 40% conduit fill. Now, these numbers don't really mean much to you right now, but you'll see where these come into play as we start doing our calculations. Okay, but just keep Table 8 in mind. There is a maximum percentage that we're allowed for conduit fill. Okay. All right, so let's go back to the rule here, 12.9.10, sub-rule 4. So yeah, basically Table 8 tells you the maximum that you can fill it, right? If we go through these items here, the usable interior cross-sectional area for allowable fill for various types of conduit and tubing shall be as specified in tables 9A to 9H. Now there's a lot of tables in there. I'm not going to go through every single one, but we'll bounce to one here, just kind of give you a little overview, because 9A to 9H, they're all the same layout, but what is different is conduit fill percentage. All right, so we'll look at a few of these tables here. So on the left column here, you basically have your nominal trade size conduit, and here in Canada, it's all in metric. But, you know, starting at 16, I know that's a 1/2 inch, then 3/4, 1 inch, 1 1/4, 1.5 inches, 53 mils, a 2-inch conduit, and so on. Okay. And then when you go along the top here, the heading of each column, we have a column for rigid metal conduit. We have one for flexible metal conduit, rigid PVC, different types in here. DB2 ducting is pretty common for underground installations. Liquid tight, metallic, liquid tight, flexible, and then EMT, and then non-metallic tubing. And then when you go down each column here, so if we just take a rigid metal conduit, all right, the internal diameter gives you your internal diameters of each trade size conduit, and then based on 100%, the area there's your millimeters squared. Okay, if I keep going through the tables here, this is the exact same thing, just you got a few more options. So 9A and 9B are the same. You get to 9C, now it's based off 53% conduit fill, but same options for conduit, so the next two are the same, but based on 53. Keep on going, now we're based on 31%, and you get to 9G. This is where you're going to spend most of your time, because the majority of us are going to be installing 3 or more conductors in a raceway. So you always hear the term out in the field, 40% conduit fill. So 9G, 9H, this is where you're going to be living quite a bit when you're doing these conduit fills. right? But other than that, the tables are exactly the same. The only difference is your percentage, all right? I should mention, I'm not going to reference it much, but there is table 10A. It's kind of left over from previous editions. And it's kind of structured the same way. It's based on conductor size, right? And it gives the diameter of those conductors and the area that it would occupy in a conduit, right? And then you have your different types of insulation along the top. Okay. Where does that come into play? I say it's an older rule. Well, let's keep reading the rule here and I'll show you. All right, so keep that table 10 in mind. If I come back to here, so that items A talks about the interior fill for conduits, different types of conduits, and based on what you're allowed to fill it up to, which comes out of table 8. Okay. You could, if you have a spec sheet from the manufacturer, you could use those values that they provide as well. That's what item B is saying. Item C now talks about the cross-sectional area of insulated single conductors and cables. Right? I kind of showed you a little bit of table 10, but they added tables 6A to 6K over the last couple revisions of the code book. So let's go look at those. So in here, 6A to 6K, laid out exactly the same. On the left column, you have your conductor size. All right, so 14 gauge, 12, 10, 8, and so on. And then the diameter of those cables, each cable, and then the area it would occupy as a single conductor. Right, so you got this, number 14 would occupy 8.87 millimeters squared. And its diameter for that single, say a T90, well not T90, we'll say R90 XLPE, would be 3.36 millimeters, right? So you go along here, and before I go to here, let me just tell you what the difference is between 6A and 6K. The only difference with each table is what type of insulation is on the conductor. So 6A is used for when you have R90 XLPE, RW75 XLPE, it's 600 volt rated, right? There's a lot of detail up here you have to pay attention to. Down along here you have the number of conductors, and what's nice about this compared to table 10 is there's no math you really have to do. Table 10, you would have to take your size conductor, find out its area, and multiply by the number of conductors within that conduit. All right, here, if you know that you're going to have 6 of them in there, 6 number 10s, and they're R90 XLPE, you just come down to number 10, slide over to 6, and there you go, 94.16, right? And you'll see where these numbers come into play, but just as an example. Because, yeah, I could go to tables 10, so we'll say R90 XLPE. I'll just bounce around a little bit here. So R90 XLPE, number 10. Here I have to take this and individually multiply. All right. So table 6 is an easier table to use when you have multiple conductors going in of the same size. Okay. So 6A, that's the insulation type, and you just go through each table, and just this is where you really have to pay attention because everything else is laid out exactly the same. Okay, so this one's for 1,000 volt rated. Go with 6C. That's for jacketed conductors. So I believe the other ones were unjacketed. Yes. All right. So you got to pay attention. Does the conductor have a jacket? Yes or no? What's the voltage? Is it 600 or 1,000? Right. So those are little details that could trip you up. Then we get some TWU, TW75, and so on. So there's quite a few tables in here, but as you can see, they look exactly the same. The only difference is what is the insulation type. Okay, get down to 6G, I believe. That's where you're going to spend a lot of time because, well, 6J, we use a lot of TW75, TW, and then you get into the T90, TWN75, right? So 6K is pretty common for when you're doing your calculations. Okay, back to here. 910, so Again, table 8 is based on the maximum permitted conduit fill that you can do. 9A is based on the interior cross-sectional area of different types of conduits. If you don't know it, or even if you do, you are allowed to use the manufacturer's listed specifications as well. 6A is the different types of single conductor diameters and the area that they would occupy. And then table 10 we kind of looked up as well. Very similar, but 6 is nice because it has multiples. It does the math for you. Okay, so that's what we're going to look at here. And we are going to do a few examples. So I'm just going to slide this out of the way. And we'll do some of these examples step by step. Okay. All right. So on this worksheet here, I got various scenarios that you could run into. All right. All these different scenarios. And we're going to go through each one. Not very difficult. I basically have a gauge of wire, how many, the type of insulation and the voltage rating, and then what conduit is it going in. Because when you go look at table 9, for table 9s, you'll see that there is a difference on internal diameter between even like a PVC and an EMT conduit. Right, so that's where these tables came out. Before, they never used to have this. It was just what is the pipe size that you need, right? But now they've broken it down into different types of conduits, different types of pipes. Okay, so let's do this here. So key information that you'd be looking out for in these tables is what size wire and how many, right? And then you need to know the insulation and sometimes even the voltage rating. Because as you see in tables 6A to 6B, they were the exact same insulation, but they had different voltage ratings, or some had jacketed material and some did not. Right, so you got to watch for that. Okay, so I have 3 number 6s, 3 number 6, and I also have 3 number 14s. Okay, 3 number 6s, 3 number 14s. The first step you're going to do to solve this is let's go find the area per conductor, right? Based on this insulation type right here. So R90 XLPE unjacketed 600 volt. So I'm going to jump over to 9A and I'm going to go through, or sorry, 6, table 6s. And I'm going to go through until I find, so here's R90 XLPE unjacketed, right? And did we say it was jacketed? Yeah, unjacketed 600 volts. Okay. So in here, we're on the right table. Now all I'm going to do, and I kind of need to shift this onto the side a bit, is we're going to look for number 6 and number 14. Okay. So if I go down to number 6, conductor size number 6, each one of those would occupy 37.94. Okay, 37.94. So I come back over here, I'll just put 37.94, and actually I could probably write that right on here, 37.94. And then number 14, come back over here, number 14 would occupy 17.73. Or sorry, no, that's for 2 conductors, 8.87. Okay, I go 8.87, and then I'll just put it over here, 8.87. Now I'm going to multiply that number by the number of conductors I have. I could do that, but what's nice about the table 6A is it does the math for you. So we're saying there's 3 of them in each wire size. So number 6, all I have to do is go over to number 3 here. I have 3 conductors. So for number 6, it's going to be 113.81. 113.81, right? So 113.81. And then for number 14s, if you do the math or you just look at table 6A for 3 of them, it's 26.6. Okay, so that's all we've done here is just kind of multiplied by 3, or I've just gone to the table 6a under the number of conductors 3 and just found the number itself. Okay, 26.6, and then all you do is you add these two numbers. All right, so I'm going to add those two. 113.81 plus 26.6 gives you a total of 140.41. 140.41. Okay, so that's your total area, 140.41. Now what do you do with that? We're going to go to our table 9s. Okay, and we're going to go look under rigid metal conduit. So I'll slide this back over, bounce around. Now again, these are all laid out exactly the same. The only difference is percentage, and since we have a total of 6 conductors in this conduit, table 8 tells us that we have to use 40% conduit fill. Okay, so we're going to scroll down to 40%. That gets us 9G, and we're using rigid metal conduit. So that's your first option here. Now we came with a total area of 140.41. All we need to do is come down here and find a number that is greater than, equal to, or greater than. So it looks like we're going to be using a 21 millimeter conduit. That's our answer. All right. So 21, which is a 3/4 inch conduit, is good for 141.6. So 3/4, I'll put 21, but I'm used to still saying 3/4 inch conduit. All right. So that's how you do. Basically, that's how it's going to be for each one. The other thing I should mention too is what you should be paying attention to is the conductor stranded or is it solid? All right. And they actually do have two different values. So I should show you. Let's come back here. Oops. Come back here. And if I go back to the table 6s, you'll see right here stranded conductors. Stranded conductors. And if you keep scrolling down, there is actually at the end of each of these one for solid conductors for 14, 12, and 10. And that makes sense, right? Because after that, your conductors are no longer solid. They become a stranded conductor once they're above a 10 gauge. And they're usually with number 10s, right? So you think of like a 3/0 conductor, that's just a bunch of number 10s all put together to make that 3/0 conductor. But pay attention, make sure, what is my conductor? Is it solid or is it stranded? Okay, so that's one other thing that you need to look for. All right, let's do the next one. So let's start speeding this up. And what I'm going to do here, because if you don't have a code book, I guess you can purchase one, but I don't want to be flipping back and forth with the tables. But if you have your Canadian Electrical Code book, then this will be easy to follow. The steps are exactly the same. Okay. One thing I should also mention too. So we said it's 21 millimeter. If you're not sure what that is, right? Because yes, we're in Canada and it's a metric system, but we all go to the supplier and we don't order our 3/4 inch conduit. We don't go to the counter and say, "Can I have 100 feet of 21 millimeter?" We just call it what it is, 3/4 inch. Right? If you're unsure what that is, in the front of your code book, you have this page here. I'm not sure what page it is offhand, but it gives you the metric or the equivalent trade size. So as you can see, if you get a 21, the equivalent trade size is 3/4 inch. Right? Your 53, there's your equivalent trade size, that is 2. You can't do the metric conversion to imperial. It won't give you this exact number. So these are the equivalent trade sizes. It comes pretty close when you do the math. But this chart, just if you're unsure what the millimeter is converted to imperial, this chart is in the beginning of your code book. All right. Just a little FYI. All right, let's do the next one here. So what do we have? Well, we have 8 number 8s, R90 XLPE jacketed, 600 volt, and we have 6 number 14s. Same insulation type. And it's going in rigid PVC. So first step is I am going to go find, I want to know what it is per conductor. So R90 XLPE jacketed. So I'll tell you what table that is. When I scroll through my tables here, I'm in table 6s. Table 6s. And 600 volt rated. You're going to be looking at table 6C. So number 8 of them. Well, per conductor, it's going to give me 35.78. So I'll just write that in here. 35.78 for number 8s. And then for 8 of them, if I stay on the same table 6C and just scroll across till I have 8 conductors, I'll see that would occupy 286.28. And then for my number 14s, well, individually they're 13.33. And for 6 of those, they would take up 79.99. Okay, so again, I would just add those two numbers. So 286.28 plus 79.99. Add those guys up. 286.28 plus 79.99 gives me a total of 366.27. And I will slide the chart over before you look for the conduit, just so you see where I was looking at. So we had our number 8s. So I located out of table 6C, R90 XLPE, jacketed 600 volt. Number 8 individually, 37.78 or 35.78, and then 8 of them, 266.28, and then number 14s, same idea, 13.833 individually, and 6 of those, 79.99. Okay, so we add those up. All right, so with this 366.27, now we're going to go and look for on our table 9 and 9G, because again we have more than 3 conductors, and according to table 8 we have to use 40% conduit fill. So I'm just going to go to that table 9G, 40%, and I'll slide this one over. So 366.27, we need a conduit rigid PVC that's larger than that. 366.27. So rigid PVC is the third option, and it looks like we're going to be using a 41 millimeter conduit, which is good for 456.04. Okay, 41 mil. 41 millimeter, and I'll fill this in here, 366.27. And if you want to know what a 41 millimeter conduit is, again, there's that little chart, but we can see that's an 1.5 conduit. So 1.5 for PVC. Okay. All right. So next one, same steps. I'm going to bring up my sheet back here so I have it ready. So our next one, now a little curveball here. This one is solid conductor. So if you go look for the stranded, I don't think it might change the conduit size. Depends on how close to the edge we are in the calculation. Sometimes it will, sometimes it won't. But this one is saying that we are using 9 number 12 T90s, 7 number 14 TW75s. Both of them are a solid conductor. They're not stranded. Okay, and this is going in non-metallic liquid tight. Okay, so same ideas. I am going to go look for T90. So I bounce around here on my sheet. If I go to table 6K, I'm going to see that per conductor, it would occupy 7.12. That is a little thick, so I'm going to move that down a bit. 7.12. That's better. And then for TW75, if I look at table 6J, individually 7.79. Okay, so if I go through those charts again, I pull this up so you can see where we're looking at. 6 or 9, give me a second here. T90, near the end. It'd be nice if T90 is beginning, because like I said, that is the most common conductor that we're using in conduit. Alright, so T90, and we have number 12s and 9 of them. So I could, you know, just take my 8.45 and multiply that by 9, or I can come across to the 9, number of conductors 9 for number 12, 76 point, oh, let me just make sure that's correct. Number 12. Oh, see, I almost made the mistake. The mistake is I'm looking under stranded, right? You gotta watch that one. We want solid. So number 12. Same idea though. So individually 7.12. Come across to the, for 9 conductors, 6404. Okay, 6404. So come over here. 64.04 is how many 9 would occupy, or how much 9 would occupy. See, I almost made the same mistake. Watch, make sure that you're looking for solid when it's a solid conductor and stranded when it's a stranded conductor. All right, number 14's 7 of them for TW75. So it's going to be up a chart. TW75, solid conductor. And we said number 14's, so individually 7.79. And then for 7 of them, 54.55. So 54.55. And again, add those two numbers up. 54.55. Add those up. Let's see what we get here. 64.04 plus 54.55. 118.59. 118.59. And I think you get the idea here of what we do next. Now we're going to go to, based on the conduit fill that we're allowed, 40%, we're going to go to table 9G. And for non-metallic liquid type, you're going to see that you would require a 21 millimeter. So table 9G, and you're going to have a 21 millimeter, which is a 3/4 inch conduit. Okay, so exact same steps. The only curveball on this one was, hey, we're not doing stranded conductor, we're using a solid conductor. And even I almost got tripped up on that one, but I caught it before I went through with it. 118.59 should be in here. Okay, next one. We have, obviously stranded because we're looking at 250 kc mil, 3 250 kc mil T90 insulation in an EMT conduit. Okay, so for T90, that was table 6K. I'll just put table 6K in here. Let me change up the color. Just keep things interesting. What do we got here? I'll go back to, let's use this color. Okay, so table 6K. And if you go to table 6K, and we have three 250 kc mil. It's T90. You'll see that that per conductor would occupy 255.6. Obviously, the subtotal, well, this is it. There's no other conductors going in with it that we need to add to, so I blanked it out. So total area would be, we're going to take this times 3, so 255.6 times the number of conductors, or you can go to the table itself and go under the number of conductors column 3, and you should get 766.8, right? 766.8. It's an EMT, and when you go to table 9G, table 9G for 40% conduit fill, you see that you're going to need a 53 millimeter conduit, which is a 2-inch. Right? Okay, so I'll just show you that really quick. See how we got there. Okay, so 6K, we'll go to 6K. So JK, so they were 250 kc mil. So individually, they're 255.6. Okay, we had 3 of them. So if I go over here, you get 766.8. So you take that number, 766.8. Now we're going to go to table 9G. And just to save from scrolling, I'll get right to the tables. And then I'll scroll from here until I get to the 40%. 9G. And we're using EMT, which is the last column. And we'll find one that is bigger than 766.8. That gets us to 822.91, which lines up with 53 mil, which is a 2-inch conduit. Okay, so I think by this point, everyone is getting the hang of this. You're just flipping back and forth between tables. And you're looking at, is it stranded? Is it solid? How many conductors do I have? The size, do a little bit of math, and then pay attention to what type of conduit, because that will determine the minimum size conduits that you're going to use. Okay, so I do have another 4 here, and for these ones, I'm just going to fill them in, but it's the exact same steps, right? So I'll fill these in. You can practice with them. But for these ones, we had 3 3/0 T90 individually. They would have been 172.96. There's 3 of them. So the total of that times 3 would be 518.89. Then we also have one number 6 T90, which takes up 32. Oh, that's a messy 2. It's hard to write with this little pen sometimes. 32.67. There's just one of them. Add these 2 numbers up, you would get a total area of 551.56. Going to look under 40% conduit fill under the rigid metal conduit, you would see that you need a 53 millimeter conduit, which again is a 2-inch. I am never going to be going to the supplier asking for 53 mil. Just old school. And that came from table 9G. Okay. Just so you know where this came from, these 2 came from table 6K. All right, in case you want to go look for that. All right, next one, let's get another color here. I'll go back to red. So we have 15 number 10 TWUs. Again, pay attention to this, it's solid. Right? And we have 6 number 12 TWs. Right? So for the TWU, you should be referencing table 6D. And for the TW, referencing table 6J. You go through those tables and you'll see per conductor it's 24.89, and for the number 12s 10.01. You do the math, so this times 15, or just go under. Actually, this one might not have the option for 15. Let's go have a look at this one actually. So TW, table 6D. Where's my tables? Table 6D, I'll slide this over. Bounce around a little bit here. Table 6D. A, B, C, D. So you'll notice you actually have to do some math here because there is no option for 15 conductors. So you actually have to take the individual, in this case you would take the individual size of a number 10, which is 27, oh sorry, I almost did it again, stranded. Individual number 10, which is 24.89, and now you would have to multiply that 24.89 times 15. And that's how you would get the 373.35, because there is no option for 15. So sometimes you do have to calculate it out. All right. Anyways, so that would work out to 373.35. And just in case you're skipping ahead in the videos, how did we get to that? I basically took the 24.89 times 15. Okay, and then for this one, obviously it's 1001. Add those two together, right? You would get a total of 433.41. Okay. You take this number, you're going to go to table 9G, 40% conduit fill, and we're using metallic liquid tight, and you will see that you would need a 41 millimeter metallic liquid tight for this, to contain these conductors. All right. And again, 41 is equivalent to an inch and a half conduit. So, inch and a half. Okay, two more. So next one, stranded conductor, RW90XLPE unjacketed. Right? Again, pay attention. You need to know, is it jacketed, non-jacketed? We have 4 3/0. It's going in DB2 ducting. So we are going to go to table 6D for this one. Table, let me switch the color. Let's see what color we can, let's do blue again. Table 6D. And you'll see that for 4 3/0, you have 220.62. Again, just take that number times the number of conductors, because this is based on the individual. So that times 4 will give you 88247. And that's hard to write in there, but just so everyone sees, 882.47. We're using DB2 duct. We're going to go to table 9G because it's 40% conduit fill. And you'll see that you need a 78 millimeter DB2 duct, which is good for 18, 24, 15. And a 78 millimeter trade equivalent size is 3 inch. So 3 inch conduit. All right, last one. Let's pick a color I haven't used yet. Let's see here. Let's try this yellow. Okay. Good. We have RPV 90, so solar panel wire. 1000 volt, jacketed, both of them. 2 different sizes though, different quantities. Right, so 3 number 8s, 35 number 10s. That's fine per area. So first off, the table that we're going to look at for this one would be table 6H. So I don't reference this very often. I personally have not done solar panel wiring, but that's where you'd look. That's where you'd find this conductor, that insulation. Okay, 6H. So you go to table 6H for number 8, 3 of them. Well, per conductor, it's 44.3, and 3 of those would equal 132. I don't like that 3. 132.89. And then for the number 10s individually, they're 28.18. And for 35 of those, 986 0.3. Maybe if I zoom in on here, make it easier to write. Let's try this. That's a little better. So trying to fit everything on there. Okay. Add these two numbers up, you would get 1,119.19. Okay. Again, we're going to go to table 9G. We have more than 3 conductors. We're using rigid metal conduit. When you go to table 9G, you will see that you would need a 63 millimeter conduit, which is good for 1255/62, right? It's larger than our calculation. And a 63 millimeter is the trade equivalent, would be 2.5 inch. So you would need 2.5 inch, or if you want to talk metric, 63 millimeter rigid metal conduit. Okay, so really that's all there is to it. It's not a complicated process. Probably one of the easiest things to do in this trade, conduit fill. But you just take those same steps, and again, the things that you really got to watch out for when you're doing this that would trip you up is, especially the first couple tables, it's very similar. It's either jacketed or unjacketed, or it's 600 volt or 1000 volt rated. And the other item that would possibly trip you up is stranded or solid. Other than that, the process is exactly the same. All right. So I hope that helps. I hope that clears this up. I'm going to have another video out soon on doing box fill calculations, which is rule 12, 30, 34. All right, so watch for that in a few days, and we'll get that posted. And we'll see you next time.